In this problem we have two converging lenses, and they're separated by a distance L of 24 centimeters, and the focal length of each lens is 12 centimeters. So this one has a focus here, and the second lens has one as well at the same spot because it's actually half the distance, right? So the focal length of these is at the same spot, so that's why I drew that there, F1/2. Here's the other focus of the second lens. So the object is at a distance of 36 centimeters from the first lens. So anything associated with the first lens I give subscript 1, second lens subscript 2. And we want to find where the final image is relative to the lens on the right. So it's a two-lens system, but I ignore the second lens to start with and just focus on the first lens. Only worry about the first lens. Where's the image going to be for that one? If it turns out being way over here, that's fine. That'll just be our object for the next lens. So I just take a look at the first one. So I have my equation, 1 over F equals 1 over P plus 1 over Q. Okay? And so for the first lens, it's F1, P1, Q1. So we know F and we know P. So we can just call it F since it's all F. So I want to find out what Q is. So I'll solve for Q. Q1 equals, so it's 1 over F minus 1 over P1, and then since I've inverted the Q1, I invert that. Okay. Plug in my values. 1 over 12 centimeters minus 1 over 36 centimeters. Inverse. So Q1 turns out to be, after we plug those numbers in, invert it, 18 centimeters. Now this is a positive number for a converging lens, means we go to the right of the lens, so we're going 18 centimeters from here is where our image is going to be formed. And we know this is 12 centimeters, so it's going to be like halfway in between here. So it's actually going to be here somewhere. So I'll just draw out my ray diagram now that I kind of know exactly where it's going to be. So it goes through the focus, and then through the focus, through the center. Well, I won't go through the center because that'll go through my writing. But here's our image, right? So we can call this now Q1. But that Q1 becomes P2. That becomes the object for our second lens. So we'll call it Q1 slash P2. Okay? Now we know that we need to figure out the distance. It's not, P1 is not just 18 centimeters, or P2 is not just 18 centimeters, because we're not 18 centimeters away from this lens. We can say that this distance, this length L, is going to be equal to Q1, because this is Q1 to here, and P2 to there, plus P2. Okay? So Q1 goes between here, P2 between these two. So we can say P2 is just length minus Q1, which makes sense if you think about it. If this total distance is 24 centimeters, and this distance is 18 centimeters, the leftover is just P2. So that's just 24 centimeters minus Q1 of 18 centimeters. So P2 is just 6 centimeters. Okay, so we're going to use that in our next equation. So we do the same thing, 1 over F equals 1 over P2 plus 1 over Q2. So we're looking for Q2 now. Q2 equals 1 over F minus 1 over P2. Again, inverse. Q2 equals 1 over 12 minus 1 over 6. Put in centimeters, 6 centimeters. Inverted. So it gives me a Q2 of negative 12 centimeters. Okay, so this is actually within the focus of the second lens, so our image isn't going to be formed over here, it's actually going to be formed over here. So if we draw this out, we go parallel through the focus, and that comes through here, and if we go through the center, comes out to there. So that's actually going to be our drawing, negative 12 centimeters. So our image is formed right in the center of those two. Final answer.